Okay, let's prove that there is an energy present in a magnet. One of the best ways to show this is the presence of motion. We see something actually move because of the energy. As we saw earlier, like poles resist each other, they repel each other, and unlike poles, attract. So we have a magnet here. This is nothing more than a plain old refrigerator type magnet, and we have a small bar magnet. And I don't know if this is the north or the south pole, so let's find out. Let's take the north pole of this one and see if it will attract that one, and it does. So this must be the north pole. Now let's try the south pole and see what happens. Oh, it didn't like it. See, it just pops away. Okay, it likes the north, but it does not like the south. So let's flip this over, and yep, the north pole pushes that away. So this is the south pole, and the north pole attracts it. And this is the south pole, and south, it resists, it pushes it away. It repels it. So if we take this and flip it over and we try the north pole on this side, again, it pushes it away. Not quite as strong because there's some non-ferrous metal in the way, but as you can see, it does push it away. So there is an invisible force here in magnets. It is called magnetic flux, and there are lines that come out each end of the magnet, and they go around and they meet in all directions, in this direction. So under here there's also lines of magnetic flux. And the way we produce electricity is we let a piece of wire pass through that magnetic field, and it induces a voltage in that piece of wire if it goes through a magnetic field. Okay, this is an electromagnet. It is nothing but a piece of ferrous material in the center, which in this case looks like a piece of steel. Has a coil wrapped around it, and that coil goes back to a power supply, which is a 24-volt power supply. And of course, the coil in here has to be rated at 24 volts as well. And as you can see, when there is no power applied, it doesn't pick up anything. All right, let's turn the power on. Okay, when we turn the power on, it has magnetism. As you can see, it picks up pretty much all of that. Now, if we get rid of that magnetism, if we turn that off, as soon as the power dies down, see, they all fall off and we are no longer magnetic at all. And it has the same properties as any other magnet, has a north and a south pole. Let's see if that's true. Okay, let's turn the power on. And let's see. Oh, it must be a north pole on the magnet because it's the south pole attracted it. And the north pole definitely repels it. It does not want to go near the north pole, but the south picks it right up. So, all right, now let's prove a point here. Let's switch polarity. And by polarity is we're going to take the positive and put it on the negative, and the negative and put it on the positive. Okay, so we're sending the current through in a different direction. Instead of, at first we had a positive and a negative, now we have a negative and a positive. All right, let's apply power again. And this time, see, it pushes the south pole away and it attracts the north pole. So when you see, it doesn't want to do this. See, that attracts, that repels, that pushes it away for sure. See, it won't go to it, but if you go to the north, it goes right to it. So if you switch the polarity on an electromagnet, it changes the pole. In one position, this is the north pole. In the other position, this is the south pole. And again, it's in the south pole right now because the negative attracts and it repels the like pole, which is the south. So that's what an electromagnet is.